My name is Mike Evans. Hopefully you're all in the right place. This is Kotlin for Android developers. I highly recommend you stick around to the end. I got stickers and cool things to give away. So who here has heard of Kotlin? Anybody? All right, that's a small amount of people. So what it is, it's a programming language written by the makers of IntelliJ, JetBrains. They also are where the IDE Android Studio comes from. And their goal is to go out and create a language that is 100% interoperable with Java, but without a lot of the kind of warts of Java. So, you might be thinking like, why use another language? I'm pretty comfortable with Java. Been doing Android development for some amount of time, or maybe just back-end development. So there's quite a few problems. Java has mutability problems. Everything by default pretty much is mutable. It leads to some issues. The language, I don't think anyone has ever called Java like concise, very verbose. And Android specifically, you don't have any control over the platform types. That usually leads to a lot of utility classes, like some are even present in the Android platform themselves, date utils, string utils. So you have no control over those classes. And then probably the biggest one is nullability. You've probably seen a null pointer exception in your code. It's like references the $1 billion mistake. I think everyone has probably seen this before. And then not just like maybe bad things about Java, but Kotlin supports tons of things, and like don't even bother if you don't know what all these things are. We're going to talk about a lot of them, but there's quite a few things that Kotlin has that Java doesn't, that like modern programming languages do. So let's get started talking about the language, and maybe then it will become a little bit more obvious why it's good. So if you're getting started, you might think, oh, it's probably a lot of work to get a new language in your Android app. If you worked with Groovy or Scala in the past for Android, you saw there's probably a lot of ceremony and a lot of like difficulty getting it going. All you really need to do is add a Gradle plugin and one runtime dependency or standard like compile dependency, and you're pretty much off to the races. You can just start creating Kotlin classes immediately. Android Studio and IntelliJ have support for it out of the box, so you don't need to install any like plugins or anything like that. It should just work at that point. So once you have Kotlin set up, you might be wondering like how do you write some code? Like what's the syntax look like? So we're going to do a little crash course on the syntax. So this is a method declaration in Kotlin. Probably can infer what this does, but you may notice that the variable name comes before the type in Kotlin, which is different from Java, and the return type is at the end of the signature, and that the signature starts with fun. And one neat kind of trick while we're kind of talking about functions is if they're one line in Kotlin, you can actually omit the return statement and the curly braces and just inline the whole thing. Declaring variables is also different. So in Java, you may see code like this, where you have final to declare that it's a constant and can't be changed, or just an int. Kotlin has slightly different support. It has val and var, and val indicates that the type can't be changed. It's a value type that can't be changed, and variables can be changed. The other thing that Kotlin supports is type inference. So in this case, we say that A is an integer type. Because Kotlin knows that it's an integer type, we can actually just omit that and just say it's 1. So you don't need to specify. Moving on to classes. Kotlin doesn't have doesn't have fields. It has a concept of properties. So this is probably a very simple Java class you may see as a field, simple field, getter, setter. So like I said, Kotlin doesn't have fields. It has these things called properties. So you declare the same class like this, and you don't use getters and setters. You actually use a dot notation, and so that's sort of a much simpler way to look at it. You don't have to write all these getters and setters. Another language feature that you may have seen if you worked with Python, Ruby, Groovy is string templating. So instead of concatenating lots of strings, you can just, in the middle of your string, use the $ bracket operator or curly brace operator, and you can just evaluate expressions inline, and you don't need to concatenate a whole bunch of strings. So now we're going to move on to probably the big one that I talked about earlier, nullability. So a goal of the language is to make the null pointer exception kind of happen at compile time so you can catch it rather than at runtime. So the way that they accomplish this is by building nullability into the type system. So in Kotlin, all types cannot be null by default. That's not a valid value. So if you have a string, in this case, it can't be null. That won't compile. But if you add a question mark at the end, that makes the type nullable, and then the value can be assigned to be null. So if you have this code in your IDE, second line where you're trying to assign a string to null, that will give you a compiler error. And if you, now you need to, you're probably wondering like how you deal with nullability. I mean, you can do the Java type, like do a whole bunch of if checking, but it's not very fun. No one wants to like litter their code with stuff like this. So there's quite a few different mechanisms that Kotlin has to handle null. The first is called the safe call operator, and that's denoted by question mark period. And basically what it does is if that value is not null, it will call that method, and otherwise it won't do anything. What's cool about these is they're chainable, so you can actually just run several. If you have like nested objects, and if person is null, nothing will happen, and if person is not null and name is not null, then it will print the length. An alternative is what's called the Elvis operator, and that is kind of like a ternary operator on steroids. It's the question mark colon, and basically if the left side is not null, it will use that, and if it is, it will use the right side. And if for some reason you're really a big fan of seeing null pointer exceptions in your stack traces, you can still cause that to happen with the exclamation point, double exclamation point, and if that value is null, that will throw a null pointer exception. So if you miss it, you can have it anyway. Another cool language feature is default values. So when you define method signature, you can provide a default value. So in this case, we're going to define a function called toast that takes a message and a length. And by default, if you don't specify the length will be short, and it will just delegate to calling a toast. So you can call the method like this. You can pass nothing. You can pass explicitly, or you can even pass with the name. Pretty cool, pretty useful sometimes. Next thing, and probably the thing that got me very interested in Kotlin for Android, is extension functions. So you can, if you've used C# before, you might have seen something like this, but you can define functions on existing types. So in this case, we define a method called swap, which takes 2 indexes, and on any list object, you can now call the swap method. It doesn't exist in the standard library, but you can use it anyway. So this becomes pretty powerful. You're pretty much unbounded with what you want to do. So maybe you wanted that toast method. Maybe we want to add it to activity now. So instead of having to, you can now just call this toast method in any activity without having to remember the show, to make sure you call show or anything like that. Pretty neat, pretty powerful, and we'll talk a little bit more what kind of cool things you can do with that in a bit. And I think the last main thing I want to talk about is probably the highest level, is function expressions and higher order functions. So in Kotlin and like other languages, you can actually make a function a variable, which is not something you really can do in Java. So in this case, we're going to have this function that just checks if something is empty, and you can define these and assign them to variables. So the syntax here we're saying is that we're defining a function that takes a string and returns a Boolean, and so these functions are assigned to variables so we can use them later, and we'll see in a second how they're used. But we define these functions as like if the string is empty, or the string has a length that's exactly 10, or if the string is a palindrome. And where these become super useful is when you have higher order functions, which are present in a lot of modern programming languages. So for instance, the filter method, and what this does is it takes a list of a given type, so let's say string, and you pass it in a function that takes a string and returns a Boolean, like one of the ones we assigned. And basically what the method does is it creates like a new list, and it iterates through the list and calls your function on every single item. And if it matches, then it will basically add it to the new list and return it. So it's filtering out things that don't match the function you pass in. So we can do something like this, where we have a list of names, and then we can either pass in the function, or we can do it inline like an anonymous class maybe would look like in Java, and it allows you to pass around these functions and maybe reuse them. So it's pretty powerful, and again, we'll see in some examples for Android where that might be useful. So the first one I want to talk about is kind of using extension functions. So has anyone ever used Picasso or any image loading library on Android? You might be familiar with code like this. Pretty self-explanatory. Just uses Picasso to load an image URL into an image view. But wouldn't it be cool if we could have the image view do that ourselves? So we can actually define an extension function on image view called load that takes the string and actually calls into Picasso. And now in Java, we can just call imageview.load. We don't need to know about Picasso at all. We can now switch to glide and not have to worry about it. So it's kind of a neat trick. Another one, talking about the passing functions around. So let's define a function called sports lollipop. And in this case, we're going to pass, it's going to take a function that takes anything and does nothing. So unit is kind of void in Kotlin. And basically what happens is if the SDK version is higher than lollipop, we'll run your code, and otherwise we won't. And so it allows you kind of have this neat language set up where you can say anything inside this block will run only on lollipop and higher. So you don't have a whole bunch of if statements they have to maintain or anything like that. Another example might be if you use recycler view, you may have seen code like this. Maybe the mechanism that you use to handle clicks, since recycler view doesn't have a click listener but out of the box, is to define your own interface. And then inside your adapter, you create an instance of this, whether it's an anonymous class or not, and you have this callback. We can actually rewrite this a bit in Kotlin to just use the block syntax that we talked about. So it would just look like this, where you just pass in whatever function you want. And it's pretty simple. Instead of using an interface, we can just use a function that takes the contact, and it looks something like, the implementation looks a little bit like this. And then the last one, the last example I wanted to give is probably the most mind-blowing, but it gives you the power, kind of shows you the true power of what kinds of neat language tricks and things you could do, and how you can augment the Android SDK using those extension functions in combination with the higher order functions. So if you worked on Android, you probably ran into shared preferences, kind of like a de facto key value store. You can put strings or integers or booleans or whatever in it. It has a little bit of ceremony around it. There's a shared preferences object. In order to manipulate them, you need to get an editor with the edit method. Then you can modify the editor, and then at the end you have to make sure you call commit or apply. You've probably seen cases where you may forget to do that, and then you notice that none of your values get saved. So this is a prime example of a place we might want to be able to use some of these things we talked about to remove some of the ceremony and make the experience a little bit nicer. So first thing we're going to do is we're going to create a function that takes a function on the shared preference editor, and we'll call that edit method, then call our function, and then call apply. So that allows us to change our shared preferences call to look something like this, where we have this edit block, and then anything that is called inside of that edit block would be called on the editor. So we can put some strings, we can remove some stuff. Makes it a little bit easier. You don't have to remember the apply stuff or edit or anything like that. But we can take this a step further. So if you worked with the support library, there's a class called pair, and basically it's just one object to another object, like a simple map. Kotlin has support for this. It can be written out as foo to bar with the English word to. So what we're going to do is we're going to find another extension function on editor called set, which takes a pair of strings and just calls put string on it. And that allows us now to rewrite our extension, our preferences setting code to look like this. So it's a little bit more like English, a little bit more easy to grok when you look at the code base. You don't have to remember the ceremony or anything like that. It's a little bit more a nicer syntax. So really the kind of message is you can make up these DSLs or any sort of extension functions you want to kind of make the Android framework a little bit nicer to work with. There's also quite a few libraries that have already been written in Kotlin. A lot of the Java libraries, pretty much every Java library just works out of the box, but there's some Kotlin-specific ones that take advantage of some of these things that I've been talking about. So the first one I want to talk about is Onco, and it's a library written by the JetBrains people themselves, and it does a couple things, but the one thing that I think is really interesting is they actually allow you to create layouts in code. So if for some reason you really don't want to use XML, if you've ever tried to create layouts in code, you know there's a lot of verbosity creating layouts, setting the layout parameters on all the objects. You have to create all the objects kind of smallest to largest so you can add them to the parents. In this case, you can use that kind of clean kind of builder language syntax to create layouts like this. It's very easy to quickly scan and see all the properties and see how things kind of are nested. And then the other one that is really cool is actually, it's a Gradle plugin as well, but it allows you to kind of import your views by ID in your XML as like Kotlin fields. So you can actually, if you had a layout file called activity main and you had a text view with the ID text view, you can actually just use an import statement and it will import all the IDs, and then you can just call methods on there. There's no find view by ID lookups or having to use something like butter knife or anything like that. You can just kind of use them as if they were variables in your class. So earlier I talked about getting started, that you just have to apply a plugin. Yeah, it's really easy to get started, but I know that a lot of people out there are probably skeptical to start writing in another programming language in their production application probably. Might be a little wary of like how it might play out. So let's talk about maybe ways that you can kind of get started in your own app already. So the one thing I talked about earlier was about Java interoperability. Like you might be wondering, well, I have this existing Android app written in Java. Like how hard is it going to be to work with this new Kotlin stuff? It's pretty easy. So if like you had a Java class in your existing app called person and had a setter, Kotlin can just call it as if it was a Kotlin class. It doesn't know any better, and vice versa. If you have a Kotlin class, you can create it in Java. In Kotlin, you use the dot notation, but you actually can use the setters in Java. It does like this compile time magic to do that for you. So that just works. You might be wondering, how do the extension functions work? There's no way to add those methods on like Android standard library classes in Java, so how does that work? So what happens is if you create an extension function in a Kotlin class, so let's say we have this date_is_Tuesday method and defined in dateExtensions.kt, the Kotlin compiler will actually spit out a class called dateExtensionsKT.java, and it has a public static method that you can call from Java. So you have the same thing. What's neat is there's a handful of annotations that Kotlin supports. So you actually can annotate this with the JVM name annotation and allow you to change the file name. So if you didn't like dateExtensionsKT, you can actually just change it to whatever you want. And if a good place to start with this stuff is implementing your tests, because everybody here is writing tests, right? Everybody has tests for their Android app? Of course you do, yeah. A couple people do at least. So it's a good place to start because that way it's not actually touching your production app if you're really wary. Another cool place to start is what Kotlin calls data classes. So, keep going back to this person example. You probably have a class in your code base, maybe like this, has a couple fields, some getters, probably no setters, maybe. But this isn't really the whole story, right? If you have Pojo in Java, you really need a few more things. You need an equals method and a hash code method and a toString method, right? And everyone's writing those and maintaining them properly. Probably looks a little something like this, a lot of generated code maybe from your IDE. And every time you add a field, you're remembering to update these, right? Probably not. So Kotlin has this thing called data class, and you just pop the keyword data in front of your class, and you put your fields in the constructor, and all that stuff kind of just generated automatically behind the scenes. You don't need to write it. You don't need to maintain it. You get the toString, you get the equals, all that stuff. You don't have to do anything. So a good place to start is just delete your entire, basically all your signatures of all your equals methods and stuff and drop the data keyword in the front. Really easy to revert if you decide later that you don't want to. Other places to look, the IntelliJ and Android Studio Kotlin plugins have an action called convert Java file to Kotlin. I wouldn't recommend doing this for your entire project. You can, but it's probably not a good first place to start. But if you're going to get stuck and say, I wonder how this code might look in Kotlin, you can just run that action on a block of code or on an entire file or maybe a package, and it will kind of spit out the corresponding Kotlin code. And then really brand new actually is part of Gradle 3.0 is now you can write your build scripts in Kotlin. So if you've ever had to screw around in your build.gradle file, you notice maybe autocomplete doesn't work properly because Groovy is a somewhat dynamic language, things like that. But if you use Kotlin for your Gradle plugins and Gradle scripts, you will get autocomplete, and it's kind of a nicer experience. So if you're looking for some more information, the kotlinlang.org website, really good resource. they have this thing called the Kotlin cones, and they're kind of these, it's a big project with tons of like really small examples of each of the language features that I was talking about, and allows you to kind of introduce one by one, solve these really simple problems. And then as you go through the problems, they kind of mix and match some of these language features so that you can learn a little bit more about like kind of mixing them like I talked about in the examples. And there's a really great ebook, Kotlin for Android developers. I didn't write it, I'm just plugging somebody else's book, but you know, it talks a little bit more about how some of these things can be applied to Android. And I know I went really fast through all that. It's really hard to teach an entire programming language in the time allotted, but I'm hoping that you guys will have a lot of questions for me. If you get asked questions, I can give you some stickers, and I have these like pamphlets with some language resources and references on them, and you guys can come up and grab them. So there's my contact information. Also, feel free to shoot me a tweet or email or whatever if you have any questions. I'd be happy to talk about Kotlin stuff. So, any questions?